Tell me again what kind of camera you have.
Oh, my mom actually used it. It's an iPhone 6.
Really?
Yeah, it has a really good camera.
I know it, but notice the quality of this picture.
Yeah, it's weird.
I suspect that she doesn't have it set on the highest resolution.
Yeah.
Is it a new camera, or is it something she's had for, well, it can't be that old because it just came out a couple months ago.
Yeah, she's had it for about a few weeks now.
I've seen this problem with other new iPhone users. Either two things are going on. One is she's not holding it still enough when she takes a picture, or the other is that she doesn't have it set on the highest resolution.
Yeah, let me see if it has it on my phone.
Let me show you an example. This is what I get from another student. Now, there's no way that anybody else's camera is that much better than the Apple iPhone 6.
Yeah, what would it be under then?
Well, if you go to camera,
Weird.
if you go to the camera option, and you look at settings,
yeah. Oh, so
there
you
will
just gotta
be
say
a setting there that lets you control the resolution. Now, I don't have an Apple. I have a Samsung. But on my phone, it says normal, fine, super fine. I have to choose super fine.
So, camera.
Unfortunately, I don't know how to do it on the Apple. But and this is not unacceptable. I can read this. So it's not like this is a giant problem. I just know that you don't have it set on the highest resolution. And
yeah, because I'm going to settings, and then there's photos and camera. Then there's burst photos, camera grid.
Burst is where it takes like 5 shots at once and combines them all to get the best resolution. That might actually work pretty good. If you were to use burst, it might solve the problem, but I don't think that's the problem. You should be able to take a picture that has super high resolution. I know that Apple has at least 8 meg and probably 13 megapixels.
Yeah. I'm just trying to see.
Yeah.
You know, let me try taking a photo of it. Let me see if it's the same for you.
Yeah, if you can, take the same picture of this page, if you have it in front of you, and send it to my email, and we'll see if that solves it. All right? But we only have a half hour. We only have a half hour, so I don't want to spend too much time on that. Let's look at number 1.
There we go.
Okay. Now go ahead and send that to me if you can, easily.
Messages. So I get a messages, and it looks really clear.
Yeah, but unfortunately that isn't the way to tell. In other words, because it looks clear on your phone isn't an indication of whether it's going to look clear on my computer. And every single person I've had since the first of the year that's had this problem says the same thing. It looks perfectly clear on their phone.
Yeah, that's weird.
It is a little weird. I don't quite understand what's going on. I talked to my computer expert about it, and he thought that people were just not holding the camera still enough. But I don't think that's it. I think there's a setting there that you can...
yeah, that's what yeah, that's what I think too.
Why don't you investigate it? Not now. It doesn't need solved tonight, but investigate it next time.
Yeah, I just sent it, so I don't know if it's going to be any clearer. But...
Okay, let me open up my email here.
Okay.
That's my cell phone gets it before my computer does.
Nice.
Yeah, really. I actually kind of like that whistle.
That is nice,
Yeah, that's cool.
Oh, wait, did I send it to your email?
Yeah, I'm sure you did, because I just got that notice on my phone that I had an email coming in. It just hasn't got to my computer yet. Did you send it to davidcowan1949@gmail.com?
Yeah. Oh, let me see. So, let's see.
Is this your email, 3aspens82?
Might be. I don't think so, though.
All right. And you said
Oh, yeah. That's weird. I have 2 contacts of you.
all right.
That's weird.
Let's not waste any more time on it. I don't want to take away from time on your problems here.
Okay.
So what are we going to do with problem 1? We're adding 3 things together.
Yeah, so this is where I was stuck. I missed the day we did this.
Okay?
So I'm kind of lost on what to do.
Think like terms.
Okay.
Combine all like terms together.
Okay. So...
How many r squared s's are there?
2. So would it be -6 r squared s?
Yes.
Okay.
What's the next term?
Minus 2rs.
How many r's's are there?
Oh, there are 3.
Okay, add them all together. What do you get?
What 8? 6. No. Wait. Sorry, just a sec.
We got plus 6 minus
So -9 minus 9.
7. Hold on.
Okay.
Plus 6 minus 8. What's that give you? Those two?
-2.
And then plus 7?
5. -5.
Positive 5.
Or positive
In other
5.
words,
Okay.
-2 plus 7 is plus 5.
Mm-hmm.
Right?
Okay. Yeah. Mm-hmm.
So we have plus 5 RS's. And how many numbers do we have? What's the third entity?
And then -9.
Good.
Cool. Okay.
Let's look at
Cool.
number 2.
Okay. So this one. Okay, so for this one,
When I look at this,
it'd be
when I look at this problem,
because that's the only one there.
exactly. In other words, when I look at this problem, I'm going to search for the highest degree polynomial. Well, that's x cubed. That's the one I want to start with. Well, how many of those are there?
Of the, just one.
Just one. Okay. What's the next highest degree polynomial?
Then 3x squared.
Okay. What's the sign that goes in front of it?
Plus.
This negative sign has to be distributed to everything in that parentheses.
So it'd be -4x.
Minus 3x squared.
Or minus 3.
Right? That's the only one. There's no other one. Okay. Now how many, what's the next highest degree polynomial?
-3.
Well,
so plus 3.
Well, it's x.
Because it's minus 1. Oh, wait. Yeah.
Okay. What's the total on those?
That'd be 2x.
Well, there's a minus 2x there.
So, so what?
Yes.
So it'd be -5x.
Well, -6. In other words, you have to distribute this negative sign to that plus 4x. In other words, let's back up a moment here.
Okay.
Let me make sure you understand this, because this is absolutely critical for math.
Okay.
Remember I said that you can turn all subtraction problems into addition problems.
Yeah.
Well, if I change, this is the subtraction right there. If I change that to an addition, then as long as I change the sign on every single thing in the parentheses, I can take away the parentheses. So let's remove the parentheses and change the sign on every term. Well, this becomes a minus 3x squared. This becomes a minus. This
4x.
becomes a plus.
Okay.
Now, effectively, I can remove that. I don't need that plus sign anymore. I don't have any more parentheses. So if I remove the plus sign, everything left is what I've got. And I never needed these parentheses in the first place. So now start from that position. And from that position, I've got x cubed, excuse me.
You good.
And then I got minus 2x there. Excuse me, I got minus 3x squared.
Okay.
And then I've got the minus 2x and the minus 4x, which is minus 6x.
Minus 6x.
And what are the total numbers?
And then that's it. Because,
Hold on.
oh, plus 3, so it'd be plus 6.
Exactly.
Yeah.
So there's your answer.
Okay.
Okay? And that's probably the easiest way to do it. When you see a subtraction going on and there's a parentheses with a lot of terms, it doesn't really matter whether it's 1 term, 2 terms, 3 terms, or 17 terms.
Yeah.
You can change that to an addition sign as long as you change the sign on every single term and then just remove the parentheses.
Okay.
Okay?
Cool. Okay.
All right, let's see. 6x squared plus 10x minus 3. You got 3, right?
Okay.
I noticed that even when you're multiplying, they want you to use these boxes. Really?
Yeah. Yeah. They told us, or our teacher told us, she's not the best teacher. She doesn't really explain it, right?
No, I'm not saying it's wrong.
Oh, no, I know.
I kind of see why they're doing it, because they want you to use the boxes to take them apart, right?
Yeah.
In other words, to factor them, they want you to use the boxes. So in order to multiply them together, they're giving you the same technique, even though it's not really needed. In other words, every term by every term would be just as good, right? What I've tried to teach since we've been working together is just multiply every term by every term and add them all together. And that's what this does. If you'll notice number 4, you've got every term on the left, x and 3. You've got every term on the right. You multiply them together, you fill in each square, and then you add everything in there.
Okay.
Right?
Yeah. Okay, cool.
So the answer to number 4 would be what? Let's assume you've done this correctly.
Yeah, so would it be...
Start with the highest term, highest degree polynomial.
So 2x cubed plus 10x squared.
Good.
Plus 10x plus 6.
Hold on, how many x's?
Oh, plus 12x, my bad.
Hold it, there's 12 there and there's 2 there.
So yeah, would it be, 14, gosh.
14x plus 6.
Yeah, 14x plus 6.
Okay, the more I see this method, the more I kind of like it.
Yeah.
Okay, I don't mind it at all.
Okay, cool.
So, go ahead and put that answer down. I noticed you hadn't filled that in.
Yeah.
Okay. And number 5, we do the same thing. And 16x, that's 16x squared.
Yeah.
What's 3 times 4x? That's 12x.
12x.
What's minus 3 times 4x? What should be here?
Minus 12x.
Okay. Make that minus 12x.
Okay.
And then minus 9 is correct. Add all 4 boxes together, you get that. That's the correct,
awesome.
That's the correct answer there. What you have, okay, that's the correct answer there as long as that says 16x squared.
Mm-hmm.
I can't see it quite. It looks like 16x to the 7th, but okay.
Yeah, it's 16x squared.
Okay.
Yeah.
So number 6, 16x squared, 12x, 12x, 9. Very good on 6.
Cool. And then
Solve the equation. Okay, this is correct.
Cool.
That's correct. For 8. Greatest common factor is 9x. Very good.
Awesome.
That's correct. 8 is.
Awesome.
Yeah. 9.
Okay. So yeah, this is where I got stuck.
Okay. Let's look at this. What's the number that's the greatest common factor?
X.
The number.
Oh, then 80. Wait.
All right. This is a mistake that you're inclined to make.
Yeah.
Let's talk about this. I don't want you to make this mistake anymore.
Mm-hmm.
If I give you 2 numbers, I'm just going to do it like this.
Okay.
And I say, find the greatest common factor. What
10.
is the greatest common factor between those 2 numbers?
10.
Good. Why? Because 80 divided by 10 is equal to 8. 30 divided by 10 is equal to 3.
Yeah.
Both of those are integers. They're whole numbers. That's what we need. Okay. The mistake that you're inclined to make, and let's talk about it so that you won't make it, is you're inclined to say, the moment I say what's the greatest common factor, you are inclined to say 80 here. Well, if I divide that by 80, that's equal to 1. That's okay. But if I divide that by 80, that's equal to 3/8. That is not an
Yeah, which isn't a whole number.
It's not a whole number. So it's got to be a whole number. Okay? So obviously, it can't be any bigger than the smallest number. But notice that if I thought 30 worked, well, it works over here. That's 1.
30 goes
but it doesn't work there. That's not a whole number. So we have to find a whole number that divides. Now, let's assume that we said 5 works. Okay? And it does. 5 is a factor. Unfortunately, what we have left can still be factored.
Yeah.
And that's the clue.
So 10
if what you have left can still be factored, I can still divide this by 2. I can divide 16 by 2, producing 8, and I can divide 6 by 2, producing 3.
Okay.
So I can take another 2 out of that. So I could say 5 times 2, make this 8, and make that 3.
Okay.
So that becomes 10, which is what we would have used in the first place had we realized that 10 was the greatest common factor.
Yeah.
Okay?
Okay.
All right. So
okay, yeah, that makes sense.
The greatest common factor. Now, if you're dealing with variables, let's talk about that for a second, because you're also inclined to make this mistake.
Yeah.
When I say, what's the greatest common factor here? What is it?
So the greatest common factor here would be x to the 5th.
No.
Well, or would be x to the first.
No. Here's the thing.
Oh.
Here's the thing that we need for greatest common factor. It's always going to be the smallest one.
Oh, okay.
The reason is that if I divide x cubed by x squared, I get x to the first. That's like a whole number.
Okay.
Okay?
Yeah.
When I divide x squared by x squared, that's 1. That is a whole number.
Yeah.
But notice that if we made a mistake and thought that x cubed was the greatest common factor, well, that produces a 1 there. That's okay. But what's this? What's x squared divided by x cubed?
So x squared divided by x over.
What do you do when you're dividing? What do you do with the exponents?
You multiply them.
Subtract them. If you're multiplying, you add them. If dividing, you subtract them.
So it'd be x over or x to the negative 1.
Aha! That's not a whole number.
No.
That's the difference. In other words, when you're dealing with variables, you're not looking for a whole number. You're looking for an exponent that's a whole number.
Okay.
And minus 1 is not. It has to be plus 1, plus 2, plus 3, plus 4, whatever. Okay, so let's review another example. If I said this, what's the greatest common factor?
X to the third.
Yes.
Cool.
Why? Because that leaves x squared there plus 1. That's okay. It's a whole number as the exponent. That's okay. It's a whole number. But notice that if you said x to the fifth,
it won't work.
This would be 1. That would be okay. But this would be x to the minus 2, because I would be dividing that x to the 3 by x to the fifth. You subtract exponents. No, it's not okay. So whenever you're looking at variables, the greatest common factor is always the smallest exponent. Okay? That's the key. The greatest common factor sounds like it would be the biggest exponent, but it's not the smallest exponent. So, back to this problem. 80x squared minus 30x equals 0. What's the biggest number?
10.
What's the biggest letter?
X squared. Just x, my bad.
What's left over?
So it'd be 10x, and then it would be in there negative 3.
Hold on. What's 80x squared divided by 10x?
So 8x squared.
No?
Or would it be? No. 8x to the first.
Just 8x, because that times that is equal to 80x squared.
Okay. Yeah, I get that now.
That's what you always have to check. That tells you immediately if you did it correctly. And notice that when we multiply, when I multiply that by that, I'm adding the exponents. There's a 1 there, there's a 1 there. When I add those exponents, I get 2.
Okay.
When I divide, I subtract. But when I am multiplying, I add.
Okay.
And what goes here?
Minus the x squared equals 0.
Hold on. Okay, I'm going to write exactly what you said. Is that correct?
Yeah, that's right.
No. When I multiply 10x by minus 3x squared, I'm multiplying, therefore I'm going to add the exponents. I would get x cubed.
Okay, yeah.
So there's nothing there but a 3.
Oh, okay.
See why?
Yeah.
Because minus 3 times 10x is minus 30x.
Okay.
So by doing the check, you can tell immediately whether you've done it correctly or not. But you have to be very comfortable with multiplying and dividing variables. Okay? So we've factored it properly. Now tell me what the solution is.
Okay, so now it would be 80x minus 30x equals 0. So that'll work. So it'd be, 8x minus 2 equals 0.
Solve for x.
Oh, yep, here we. Okay, so now you would add 3 to both sides. And then you would get x equals 8 or 3 over 8.
Okay, be very careful you don't reverse those. You do have a tendency to reverse this stuff. Okay, what's the other solution? This is a quadratic. There should be 2 solutions.
So now it would be 10x is equal to 0.
Okay.
And then x would be equal to 0.
Okay, there you go. There's one solution, there's another solution, that's it.
Okay. Okay, number 10. Cool.
You have just probably enough time.
Okay. So
what is this called, first of all?
10x squared equals 14x.
What is this called? What kind of function or what kind of an equation? Quadratic.
Quadratic
Why is
equation.
it a quadratic?
Because it has x squared and then just an x.
Yes. How do we solve quadratics? What needs to be on one side of the equation?
An x value. 0. Oh, okay.
How do I get 0 on one side of this equation?
You divide.
How would that,
or would you multiply?
How would that give me 0? Divide by what?
Yeah, you can't divide it.
No, even if I divided by 14x, I'd be left with 1 over there.
Yeah, so you have to multiply.
No, you can't multiply it and get 0. There's nothing I can multiply anything by to get 0. What do I have to do to the right side of the equation in order to make it 0?
Subtract it.
There you go.
Okay.
So if I subtract 14x from this side of the equation, I'll be left with 0, right?
Yeah.
Okay, so I got to do it to the left side also.
Yeah. Okay,
That's
that makes
what
sense.
you do. That's the key. Remember, when you're dealing with a quadratic, you want to make one side equal to 0. Why? Well, let's factor this, and you'll see exactly why. What's the greatest number that factors into that? Think about it before you answer.
2.
Yes.
Yeah.
What's the greatest letter?
X.
Good. What's left
So
over?
yeah. It would be 2x, and then 5. Just 5.
Is 5 times 2x 10x squared?
5 times 2x. So it'd be 5x.
Okay. Let's review that again. Here's what I'm doing.
Minus
10x squared divided by 2x. In other words, once you've come up with the greatest common factor, that's exactly what you're doing, is you're doing this to every term. Okay, well, 10 divided by 2 is 5. X squared divided by x to the first, subtract the exponents, gives you 5.
It'd be 5x.
Okay, get comfortable with this process of division. You have to do it on every one of these. What's the other?
And then this minus 7x.
Is 7x times 2x 14x?
Yeah, no, just minus 7 then. Okay.
All right.
I'll get that, nailed down.
Okay, I mean, look at it. 14x divided by 2x. The exponents are 1 and 1. You're going to subtract the exponents. So that's really 7x to the 0. Well, anything to the 0 power is 1.
Yeah.
So this is
Okay.
7.
Mm-hmm.
All right.
Okay. Okay.
I'm sorry we didn't get to all your problems, and unfortunately I have an 8
You're good.
o'clock that I have to go to.
You're good.
We got through 10.
Yeah, we did.
Okay. I
Yep,
think
we're
you're
good. Okay. Awesome. All right, thank
All
you.
right, Dylan. I'll talk to you later this week. I know your mom's scheduled
Sounds
another
good.
appointment. I can't remember what night it's for, but I'll talk to you then.
Yeah. Okay, sounds good. All right, thank
Bye-bye.
you.